Hey guys, in this video we're going to be going over lesson 5.6, which is solving quadratics by square roots. So a radical is any expression that has like a square root or a cube root. So a lot of times you might hear me say radical 4 instead of square root of 4. Now you need to know the perfect squares for this. Like you need to have a list of them somewhere to be able to identify. So if we list those, we have 1, 4, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, 25, 36, 49, 64, 81, 100, 121, 144, and really you can probably stop there. We'll do one, let's see, let's go to 15. 169, 196, and 225. You can go ahead and list out up to 20 if you want, but these will probably be good enough for these types of questions. So before we get into solving quadratics, you need to know how to simplify a square root or simplify a radical. So if it's a perfect square, like square root of 49, you know that as being 7. But when we're talking about quadratics, you have to include the positive and negative. So 7 and negative 7. And if you think about it, if I take 7 times 7, I get 49. If I take negative 7 times negative 7, I also get 49. So when we're talking about quadratics, if it's a parabola and you have square roots, your parabola is going to cross at 7 and negative 7 if this was a quadratic. And we'll do some actual examples with those in a little bit. Now you can also just write it like this, plus or minus 7. That means positive 7, negative 7. Number 2, 225. Square root of that is 15. We have positive and negative 15. Number 3 says 2 radical 144. So it's 2 times whatever the square root of 44 is. And so this would be 2 times plus or minus 12, because the square root of 144 is 12. And so that is plus or minus 24. 2 times 12 is 24. 2 times negative 12 is negative 24. When we have a fraction, this is the same thing as square root of 4 over square root of 9. So this would be plus or minus 2/3, because the square root of 4 is 2, square root of 9 is 3. You don't have to put the plus or minus in the top and the bottom. Number 5, that would be plus or minus 1/9. Square root of 1 is 1. Square root of 81 is 9. Now we're getting into some examples where it's not a perfect square. And this is when you need to have your list of perfect squares. So what we are doing when we have this, we are looking for the largest perfect square that goes into 112. So you're going to need to have your calculator handy. So let's see if I can get my calculator. All right, so 112, I'm going to start dividing that by perfect squares. Now, because I'm looking for the largest one, I want to divide it by the biggest numbers that I can think of. Now, I'm not going to divide it by 144 because that's bigger than 112. So let's just start with 81. We're looking for an even number. We're looking for a perfect square that goes in evenly. So 112 divided by 64. Close, but nope. 112 divided by 49. Nope. 112 divided by 36. Nope. See, I'm going backwards on your list. 112 divided by 25. Nope. 112 divided by 16. There we go. 16 and 7. So 112 can be broken down into the square root of 16 times the square root of 7. And then the square root of 16 we know is plus or minus 4. And the square root of 7 is just the square root of 7. So when I simplify, I get plus or minus 4 radical 7. Now, let's say that you don't divide by the biggest square root. Then what's going to happen is you're going to get an answer, and what's in the square root can be simplified some more. So you would have to recognize, oh, that number, maybe 4 will go into that number, or whatever. And you have to know that you can simplify it again. All right, number 7, we have the square root of 245. So 245 divided by, let's see, let's try 121. Nope. 245 divided by, I'm not going to do 100, 81. Nope. 245 divided by 64. Nope. 245 divided by 49. There we go. 49 and 5. So square root of 49, square root of 5. This would be plus or minus 7, because the square root of 49 is plus or minus 7, and then the square root of 5 just comes down. Okay. Number 8. So we have the square root of 72. Let's work with that one first. So 72, start dividing it by some things. And you can actually divide it by 36. Square root of 36, square root of 2. And the square root of 36 is plus or minus 6, radical 2. But we have this 5, so we need to multiply by 5. So that becomes plus or minus, you only multiply the 6, 30, radical 2. 6 times 5 is 30. All right, number 9. The 45 will split up into square root of 9 times square root of 5. And this becomes plus or minus 3 radical 5. But I need to multiply by 3 to get plus or minus 9 radical 5. All right, so now we're going to use that to help us solve quadratics. So quadratic equations in the form this. Let's see. F of x equals ax squared plus c. So if you're missing the term that just has the x. So these are ones when we have no x term. We don't have a plus 2x, a plus 5x. So let's finish this bullet. If x squared equals n, then x equals the square root of n. So if we're going to get x by itself, we got to take the square root. So when we're solving these equations, we want to isolate x squared, so get x squared by itself, then take the square root and put a plus or minus with it. So over here, if I have x squared minus 64 equals 0, then I need to add 64 to both sides to get x squared equals 64. And then we take the square root. X equals square root of 64 plus or minus 8. Number 2, let's subtract 8 from both sides. 7x squared equals 7. Dividing by 7. X squared equals 1. And taking the square root, x equals plus or minus 1. Number 3, let's subtract 5 from both sides. 81x squared equals 16. And then we divide by 81. X squared equals, if it's not going to divide evenly, just leave it as a fraction. And then we take the square root. We get x equals plus or minus. Remember, when we take the square root of a fraction, we just take the square root of the numerator and denominator. So 4/9. All right, number 4, let's subtract 1 to get 8x squared equals 16. And then divide by 8 to get x squared equals 2. Since they weren't both perfect squares, I didn't want to leave it as a fraction. And then we take the square root. Now 2 is not a perfect square, but there's not a perfect square other than 1 that goes into it. So we actually just leave our answer as plus or minus square root of 2. Number 5, let's add 9 to both sides. 2x squared equals 64. Now you're going to be tempted to take the square root because that's a perfect square, but we have to divide by 2 first. To get x squared equals 32. And now when we go to take the square root, we're going to have to break it down because it's not a perfect square. So you're looking for the largest perfect square that goes into 32. And that number is 16. 16 times 2 is 32. So x equals plus or minus 4, because the square root of 16 is 4, and then we have radical 2. All right, number 6, subtract 10. 5x squared equals 300. And then divide by 5 to get x squared equals 60. And then we go to take the square root. And we're looking for the largest perfect square that goes into 60. And I believe that's going to be 4. Square root of 4, square root of 15. And you think 15, I can divide 15 by something. But really, you can only divide it by 5 and 3. And neither one of those are perfect squares. So no perfect squares go into 15. So x equals plus or minus 2 radical 15. If you have any questions, let me know. Have a good day.